All right, let's work through this handout that's practicing our relationship between energy and mass and specific heat and change in temperature. And all these are going to be using this formula, and that's the place you kind of need to start for each one of those. As a reminder, the biggest part of this is knowing what each of these stands for. So Q is going to be your energy or heat. M is mass. C is our specific heat. We went over that last week. That's a physical property of objects. Determines basically how much energy is needed to change their temperature. It's a rate of how quickly or how slowly do they change temperatures. And delta T is a change in temperature. So when we get a change in temperature, what we're doing with delta T is we're looking at the final temperature, and we need to subtract the initial or the beginning temperature from that. So in this sheet, I'm not going to work out every single problem. I'm just going to make sure that it's set up properly for you and identify everything that we need on here. So in question number one, we have a mass of 250, right? That's your M because that's mass. It is heated from 22 to 68.5, right? That's going to be your delta T. We've got a specific heat of 0.235, which is your C. And the question then is asking how much heat is absorbed, and that's your Q. Right. So again, going back to your formula, which is Q equals M times C times delta T. You've got everything you need here. The only thing you have to do is a little bit of math, is to figure out what is the change in temperature. It's going from 22 to 68.5. Again, that is a temperature that's going up, so you should get a positive answer from that as well. Again, so you're going to put that in your calculator, 68.5 minus 22, and that's going to give you your delta T. So at this point, you've got everything you need to be able to do finish up the problem. You just need to do the math to put your answer here. And then finally, again, if it's endothermic or exothermic, endo means that energy is going in, exothermic means that energy is going out. If energy is going in, you're going to have a temperature that goes up, which means you're going to need energy going into it. If it's an exothermic reaction, the temperature is going to go down. And that's pretty much all that you need to look at to be able to decide whether this is an endothermic or exothermic reaction. Because if the temperature goes up, then your Q value is going to be positive. If the temperature goes down, your Q value is going to be negative. And you can use either of those to figure out the answer for that. When you get to number two, it says convert your answer to calories. Your answer for number one is going to be in joules. If you come up here to the top, which we refer to in a few times, there is a relationship here between calories and joules. So when you get your answer for number one, you're going to have your answer in joules. And anytime we do a conversion, we want to cancel out the unit that we're starting with, put it on the bottom, and change it to the unit we would like to, if we're able to, which is on top. It's a little C, calorie. And then we want to put the numbers in that show the relationship between those. And in this case, we've got 1 calorie is equivalent to 4.184 joules. Since this number is going to be on the bottom, whatever your answer was here, you're going to divide it by the answer you've got on the bottom, and that's going to give us our conversion on that one. And in that case, your answer is going to be in calories. Please try to make sure that you are answering, not just putting the numbers there, but also putting the units as well. All right, our number three, how much heat, that's your Q, does a 23 gram, that's your mass. We have a temperature change, so it's going from negative 17.4 to 0. Again, that's going to be a positive change. So to get your delta T, you're going from 0 is at the end, and then you're going to subtract at the beginning. And in basic math, negative, negative. So if we have minus a minus, it's the same thing as getting a plus. So that's why you're going to get an increase. It's going to be positive. So your delta T is the temperature is going to be going up. The specific heat is 2.03. And in this case now, we've got everything you need. So you've got your M, you've got your C, you've got your delta T, and you're going to multiply those together to solve for Q. And again, if it's endo or exo, use the same rule that you did on number one. Endo is going to be positive, exo is going to be negative. If you're converting to kilocalories, we scroll back up to the top, we've got answers in joules, but we can't go directly from joules to kilocalories. So we can go from joules to calories, and we can go from, let's see, where are we? We can go from joules to calories, and we can go from calories to kilocalories. So it's going to be a two-step conversion in order to set that up. Again, should not be super difficult, kind of like all the stoichiometry we've done. So your answer is going to be in joules. So we can get rid of joules and change it to little c calories, just like we did on number 2. And then you're going to get rid of your little c calories and change those to kilocalories. The relationship up there was that 1 kilocalorie is 1,000 calories. You're going to use your same number here that you did in number 2 to show the relationship that you have there. Number 5, in this case, we have to solve things a little bit differently, but again, it's just kind of basic algebra, because in this case, we're actually looking to answer, get rid of that, a little bit too fat. What is the specific heat? So in this case, we're actually solving for C, right? So we've got a mass of 120.4. We have a temperature change. I notice this one, it says it cools, so that's going to be a negative temperature change. So when you put this in your calculator, make sure that when you plug it in the formula you're using is a negative, and it releases 7020 J. So it gives us the Q on this one, and we're trying to solve for specific heat. All right, so we've got Q equals M times C times delta T. And again, I'm not going to plug in the numbers and work all this out for you, but in this case, you're solving for C, so we need to get C by itself, which means that you're going to need to divide mass times delta T out of both sides once you get the numbers, and then you need to divide mass by delta T over here. So when it gets rearranged, you're going to have your Q value, and you're going to divide it by mass times delta T. That's going to give you your C value. Now, it's asking for what substance it is, so we can use our table down here to figure out what the substance is. The specific heat here, this can be a positive or negative number because it depends on if it's heating up or cooling off. So it doesn't really matter if you have a negative number, and you actually should get a negative number in this problem because you have a negative temperature. So if you have a negative temperature, you're going to get a negative answer here for specific heat. That's okay, because it actually, if you put a negative up here for negative 7020, you're not going to get a negative answer. But either way, if you got a negative or positive answer, you should be able to figure out whatever it is. So whatever your C value is closest to is going to be your answer. And again, deciding if it's endo or exo, look at your temperature change, look at your energy change. Again, it's endo if energy is going into it, it's exo if energy is going out of it. All right, last couple on the back page. 15.6 grams, that's your mass. Absorbs 868 joules, that's your energy. This one's asking for the temperature change. This is what we don't know. And it gives us the specific heat of ethanol. So again, we're solving for delta T, and so we have to kind of rearrange our equation a little bit, because if we're solving for delta T, then we need to get delta T by itself. That means we need to divide out the C from that side, which means we need to do it as well on the other side. So the M and the C are going to cancel each other out, and that should leave us with delta T being equal to Q over M times C. Remember, when you put this in a calculator, make sure that you either multiply these together first to get a number, or put parentheses around them if you're using a calculator, because if you just do Q divided by M times C, it's going to be a little bit confused in its order of operations. So make sure that you, again, either get a number here or put parentheses around it in the calculator. Endo, temperature goes up. Exo, temperature goes down. And then finally, number 7, in terms of math problems we've got here, again, same formula. Specific heat of an unknown metal is calculated to be that. That's your C. What is the mass? That we don't know. If it loses 30 80. That's going to be a negative. Um, and then there's a temperature decrease, which is your delta T. Again, you don't have to figure out the change because it's already given it to us. And again, if it's a decrease, that's going to be negative. In this case, we're solving for M, so we have to rearrange the equation again. MC delta T. In this case, we're trying to solve for M, so we need to divide the C out. We need to divide the delta T out, which means we're going to do the same on the other side. So when we finish canceling things out, we are left with Q over C delta T. That's going to equal the mass. So we're just rearranging the formula, solving basic algebra. Again, endo is going to be a temperature increase, exo is going to be a temperature decrease. Some explanation problems on number 8. If a substance experiences a temperature increase, what happens to the kinetic energy? Well, these two things are going to be related. So if the temperature is going up, that means the particles are moving around more. There's more energy going to be there. The thermometer is going to be noticing that amount of increase. So there should be a positive relationship between those two things. And number 9, if you have two lawn chairs that are identical in every way, except that one's made of aluminum, one's made of iron, I would like to rephrase this question a little bit because it doesn't say which chair will be the hottest to sit in. If you sit in it, one will feel hotter than the other because it will end up cooling off faster. So there's a couple of different ways I would like to kind of paraphrase this. But one of the ways that we can answer this, which one will transfer its energy to you the easiest, would be the one that has the lower specific heat. Again, the idea is the lower the specific heat, the easier it is to heat up and the easier it is to cool off. So if you're actually touching something that has a low specific heat, it's going to transfer its heat to you a lot more easily than something that has a higher one. So you could go back to the previous page. That's where you need to go and look at that table. And if you compare the specific heat for aluminum and the specific heat for iron, you're going to see the two different numbers on there. So again, the one that has the lower number is the one that's going to heat up the fastest. It's also going to cool off the fastest because if you're touching it, and that's going to be your answer. So you should be able to go back and look at that and give me a decent explanation for that. And with that, I believe I'm done.